All right, so in this section, we're briefly going to go over the Redshift noise texture node. You'll see I've just made a quick scene with a sink. So let's go ahead and jump into the Chrome texture, and we'll go ahead and search for noise. And for now, we're just going to pipe it straight out to the surface so we can see what we're doing. And before we dive into the settings, I'm just going to scale this guy up so that we can see the pattern. So generally, the purpose of a noise node is to add variation to your shaders without using image maps. The biggest advantage being that we can throw variation across the entire surface without having to UV the particular object or worry about UV boundaries showing up. And this is because the noise exists in world space, so all we have to do is sample each point on the surface and grab the value of the world space noise at that particular position. All right, so diving into the settings, we've got color, which is pretty self-explanatory. If I change this guy to a greeny, you'll see that my noise is being generated by two values. And in this case, we've got a green and a white. I most often set these to black and white, but in the case that maybe you want to generate a color for a surface, maybe let's say diffuse color, you can generate a color with just very slight variation. Maybe I'll make that a little more apparent. I'm not sure you'll be able to see that. There we go. So let's go ahead and flip this back to black and white. And the last option, we can also invert these colors if we like. Remap can be useful. Basically allows us to take our color output and remap the values according to our min and max here. So for example, I can clamp it down saying, okay, cool, let's take whatever value was 0.5, so that would probably be a gray in here, and that is now going to be our max value. So anything above that 0.5 is going to be 1 or white. Similarly, we can remap our min. In this case, that's our black value, and we can also say, hey, anything 0.5 is going to be our new minimum, and anything under that will also be just 0 or black. Bias just controls the ratio between the two min and max, so we can bias it toward our min or we can bias it toward our max. And then come the fun settings. Under the noise tab, you'll see we have three options. We've got fractal, which is a fractal noise, generally tends to look kind of cloudy. We've got turbulence, which I think looks kind of wormy. And we have cell noise, which is more or less a Voronoi pattern. So I'm going to flip back to turbulence. You'll see the controls underneath this are for fractal or turbulence mode only. First up, we've got complexity. And the idea here is that this value represents how many times the noise function is going to loop over itself and add additional detail. So at 1, you can see just our base pattern for the noise. At 2, you can see it's done one iteration. At 3, you'll see even additional level of detail. And at a point, we won't really start to see much more being added. So let's flip this guy back down to 3 and talk about amplitude gain. So amplitude gain essentially controls how bright each one of these iterations are as they continue to iterate. So when I walk amplitude gain up, you'll see each iteration is getting dimmer and dimmer. And if I walk it down, you'll see each iteration becomes brighter. Set that back to default. And then we've got frequency scale. So this again is referencing each one of our iterations. So right now, if I start to increase the frequency gain, each one of the iterations is going to be a higher frequency, meaning essentially smaller. If I walk the amplitude gain down so that each iteration is brighter, we'll see a bit more of exactly what that's doing. So I think default frequency scale is 2. If I walk it up to 3, you'll see each iteration is getting finer and finer. So let's go back to defaults again. And actually, I'm going to walk the complexity down to 1 for a second to talk about distortion. Distortion is basically going to warp our noise pattern. And then distortion scale, let me bring distortion back down a little bit. Distortion scale is essentially going to give us more detail in the distortion the higher we go. Let's throw this guy back down. Cool. And last we have time. Some of these don't seem to work The one that does seem to work is user time. So essentially this is just going to control the evolution of this noise. So as I walk this up, you'll see our noise just begins to evolve. It's not distorting at all. Like, we're not getting any extra detail. You can see if I have time at 1, this is loosely the frequency of our noise. If I set it to 100, we're still at that same frequency. And this could be useful for some pretty weirdo stuff, but I think the most common applications might be for, say, like a bump on that you might use for a fluid surface that you'd like to see evolve, or perhaps as a driver for volume density or scattering, so that you could see an evolution of your atmosphere, for example, without having to actually run a simulation. And lastly, we've got coordinates, and this is just telling the noise how to think about its position or how to look up its position. So the default is object position. So you'll see if I lock down my camera and let's say move just the sink faucet, you'll see the noise is sticking to the faucet, which is great because we're in object position mode. So anytime I make an object transform, the object space stays the same, and therefore we're sticking to all of our local point positions. So the next option is vertex attribute. Personally, I haven't been able to get this to work either, but in 99% of all cases, object position will do just fine. Next up's overall scale, which also does precisely as you'd expect. As I walk this up, the scale gets smaller. If I walk it down to 0, it doesn't exist, which is great. So let's put a really small scale in. Effectively, it's a multiplier on all of the axes at the same time. So let's set that guy back to 0.01 or 0.1. We also have discrete control over X, Y, and Z scale parameters for the noise. So for example, if I set the X scale down to 1, you'll see our scale is 1 on the X axis, 100 on the Y axis, and 100 on the Z axis, which can be really useful in case you want to get kind of streaky looking effects. Maybe let's say 420, there we go. And then lastly, we have the offset parameters, which if you're not happy with this look here, we can just move along, or rather offset the noise position. So if I maybe give it like a 0.01, nope, 0.1, there you go. You can see it move down a little bit. Like 0.5, we'll move down a bit more. Maybe we'll give it a little bit less variation. There we go. So in our scene here, this could be useful for adding just a little bit of maybe like rubbed or tarnished quality to our metal material here. So why don't we go ahead and use this noise to pipe into our reflection roughness. Not quite how I want it. So there are two ways we could adjust it. Remember, we've got remap and we have the original colors. In this case, I feel like being fairly precise. So let's try something like our lowest roughness value will be 35% and our highest roughness value will be 55%. Okay, maybe more than that, 70%. And we just have this nice subtle imperfection in our metal because I piped the noise into our reflection roughness.